At more than 18 billion kilometers from Earth, NASA's Voyager probes didn't slowly drift into empty space. They slammed into something. In recent years, Voyager 1 and Voyager 2 quietly crossed a boundary humanity had only imagined before, the Heliopause, where the sun's magnetic influence finally gives way to the surrounding galaxy. What they found there was not empty space, and not what scientists expected. New analysis of Voyager's data is revealing strange structures, intense particle behavior, and magnetic conditions that challenge decades of assumptions. These discoveries are reshaping how we define the true edge of the solar system and how our sun interacts with the Milky Way. In this video, we'll uncover why the solar system ends in a sharp, fiery wall, how the galaxy itself pushes back against the sun, and why magnetic fields at the edge behave in ways physics never predicted. For decades, scientists believed the edge of the solar system would be gradual and diffuse. As the solar wind weakened with distance, it was expected to slowly blend into interstellar space. Voyager revealed something far more dramatic. As it crossed the Heliopause, its instruments detected an abrupt transition, not a wide region, but a narrow, sharply defined boundary. Particle densities jumped, temperatures spiked. The solar wind didn't fade away, it collided with resistance. This forced scientists to abandon the idea of a soft boundary and replace it with something closer to a physical wall. Even more surprising was what existed just inside that edge. Voyager detected a compressed layer of high-energy plasma, far hotter and denser than models had predicted. Instead of dispersing outward, particles were piling up under pressure. The solar system, it turns out, does not gently dissolve into space. It ends. This matters because it reveals how energy behaves at extreme distances. The sun continues to push outward with a constant stream of charged particles, but instead of expanding freely, that energy is being compressed and redirected. The heliopause is not passive, it is dynamic, structured, and resisting collapse. The sharpness of this boundary also reveals something deeper. Space is not uniform. Conditions can change suddenly when different cosmic environments collide. That realization reshapes how scientists model stellar winds around other stars and how planetary systems interact with their galaxies. And it raises a crucial question. If the sun is still pushing outward so forcefully at such extreme distances, what is strong enough to stop it so suddenly? The answer lies beyond the sun, in the galaxy itself. Voyager's second major revelation was this: the solar system is not expanding into emptiness. It is pushing directly against the interstellar medium, the thin but powerful environment between stars. Before Voyager, scientists assumed this medium was sparse and weak, something the solar wind could gradually overpower. Voyager showed the opposite. The space beyond the heliopause is denser and more pressurized than expected, and it pushes back hard. As Voyager crossed the boundary, it recorded a sudden rise in galactic particles and an equally sudden drop in solar particles. This was not a slow blending. It was a clean handover from one dominant environment to another. That kind of transition only happens when external pressure is strong enough to counter the solar wind directly. This explains why the Heliosphere, the sun's protective bubble, is not perfectly round. It is compressed, distorted, and shaped by external galactic forces. The solar system is not isolated. It is embedded in a flowing, dynamic environment as the sun moves through the Milky Way. Think of it like a boat pushing upstream. The engine may be powerful, but the current still shapes the wake. The solar wind is the engine. The interstellar medium is the current, pressing inward as the solar system travels through space. This discovery changes how scientists think about cosmic shielding. The heliosphere is not simply generated by the sun. It is a negotiated boundary between solar and galactic forces. That negotiation determines how much radiation enters the solar system and how well planets like Earth are protected. As humans plan missions farther from Earth, this balance becomes critical. Beyond a certain point, solar protection weakens and galactic forces dominate. Voyager provides the first real map of where that transition begins. But pressure and particles are only part of the story. The most puzzling discovery lies in something invisible: magnetic fields behaving in ways no one predicted. Scientists expected Voyager to cross a clear magnetic boundary. Inside the heliosphere, the sun's magnetic field should dominate. Outside, the galaxy's field should take over. That assumption was wrong. Instead of a dramatic shift in direction, Voyager measured magnetic fields that remained unexpectedly aligned on both sides of the Heliopause. The strength changed, the particle populations changed, but the direction stayed nearly the same. This stunned researchers. Magnetic fields control how charged particles move through space. A mismatch in direction should have produced turbulence and chaos at the boundary. Instead, Voyager detected order where instability was expected. This suggests the Heliopause is not a clean magnetic break. It may be a region where solar and galactic magnetic fields connect, interact, or reorganize. Rather than separating two environments completely, the boundary may act as a complex interface. One possibility is magnetic reconnection, where field lines link across the boundary and form channels that guide particles between regions. Another is that the sun's motion through the galaxy stretches and aligns magnetic structures over vast distances. Either way, the implication is profound. Magnetic fields regulate radiation. They shape how cosmic rays enter the solar system and how hostile space becomes for spacecraft and life. If magnetic connections exist across the Heliopause, then the solar system is more exposed and more connected to the galaxy than previously believed. Voyager didn't just measure magnetic fields. It revealed that our understanding of cosmic boundaries is incomplete. The edge of the solar system is not a wall, not a void, and not a simple divide. It is a living interface, shaped by forces we are only beginning to understand. Voyager's greatest achievement may not be how far it traveled, but what it revealed. The edge of the solar system is not a fading boundary. It is sharp, energetic, and defined by constant tension between the sun and the galaxy beyond. Voyager uncovered a compressed plasma wall, a powerful interstellar pushback, and magnetic behavior that defies long-standing theory. Together, these discoveries redefine what it means to leave the solar system. They show that our cosmic neighborhood is not isolated, but deeply connected to the structure of the Milky Way. Launched decades before modern space exploration, Voyager is still sending data into the dark, still rewriting what we thought we knew about our place in the universe. If you enjoyed this video, support us with like, share, and subscribe. It keeps our journey going. Thank you for watching. See you next video.